गुड मॉर्निंग टू ऑल। सभी को मेरा नमस्कार। रियली वी आर वेरी हैप्पी। आज हम 55वां 55th एपिसोड हम कर रहे हैं, तो सभी का बिल्कुल ये संडे लाइव सेशन में वेलकम है। एंड टुडेज टॉपिक इज वेरी इंटरेस्टिंग एंड टुडे वी हैव invited very eminent personality for this talk. But before that, I would like to give you the virtual tour of the IISER Pune. So I am showing you, so this is the building of the IISER Pune, and here we conduct lot of activities for the students and the teachers. So this is our main building, and at the entrance of the main building there is a very nice quote. And what is that? The IISER Pune, fear tomorrow's science begins today. And I show this quote to you again and again because this quote is very appropriate for our Sunday series. So this is our Srimati Indrani Balan Science Activity Center, and here we invite students and the teachers from the various schools and the colleges and try to show them beauty of the science by using hands-on activity and various technologies. So this is a photograph of our one of the student workshop, and you can see the glimpse इन द आईज ऑफ द चिल्ड्रन। मतलब बच्चों को कितना मजा आ जाता है, एक फोटो से आपको पता चलता है कि बिल्कुल जैसा क्रिकेट का मैच जो होता है, जीतने वाला मैच, जितना बच्चे एंजॉय करते हैं उतना ही हमारा साइंस एंड मैथमेटिक्स एक्टिविटी का डेमोन्स्ट्रेशन एंजॉय करते हैं। नॉट ओनली वी इनवाइट स्टूडेंट्स, वी आल्सो इनवाइट द टीचर्स from the various colleges and the school, and this is one of the photograph of our teachers workshop. और आज का जो टॉपिक जो है, जो मैंने आपको बोल दिया था, वो बहुत इंटरेस्टिंग है और नाम है स्टेट ऑफ मैटर। और इसके लिए हमने बुलाए हैं प्रोफेसर दीपक धर। और दीपक धर के बारे में थोड़ा बोलना है तो रिसेंटली ही रिसीव्ड वेरी प्रेस्टिजियस अवार्ड बोल्ट्जमैन मेडल, और उनके बारे में थोड़ा सा मैं आपको बोलता हूँ। Professor Deepak Dhar obtained his BSc degree from the University of the Allahabad and the master degree from the IIT Kanpur, and he obtained his PhD degree from the California Institute of the Technology from 1978 to 2016. He was in the Department of the Theoretical Physics at TIFR Mumbai. Professor Dhar's interest area is statistical physics. He worked in the area of the fractal, cell organized critically, percolation and animal problems, and the slow relaxation in magnet and the glasses. Professor Deepak Dhar is presently distinguished emeritus professor at the physics and NASI-Senior scientist at IISER Pune. As I mentioned you, very prestigious award Boltzmann Medal 2022 he just received. So with this brief introduction, I would like to invite Professor Deepak Dhar. Please start your session. Now it's over to you, sir.
Okay, thank you very much, Ashok. I am very happy to have this opportunity to talk with you, and please feel free to ask questions. अगर आपको कुछ सवाल पूछना है तो हिंदी में या अंग्रेजी में पूछ सकते हैं चैट बॉक्स में, and use it regularly. Okay, जो ये लेक्चर है ये रफली 8th ग्रेड या 5th ग्रेड से आगे के बच्चों को समझ में आ जाना चाहिए। लेकिन अगर आपको कुछ दिक्कत होती है या कुछ शंका है, सवाल है, तो प्लीज़ आस्क एंड आई विल ट्राई टू डू माय बेस्ट टू एक्सप्लेन। ओके, सो लेट अस स्टार्ट। दिस इज कॉल्ड स्टेट्स ऑफ मैटर। नीचे नहीं चल रहा है, इस पे आएगा शायद। जस्ट 1 सेकेंड, इट इज नॉट, दिस स्लाइड इज नॉट मूविंग। ये क्या हुआ? इट इज नॉट मूविंग नाउ। ओके, सो ये जो लेक्चर है इसकी आउटलाइन है। आई विल स्टार्ट बाय सेइंग व्हाट आर स्टेट्स ऑफ मैटर। पदार्थ की अवस्थाएं कौन सी हैं, we will start by asking the simple question, why are there three states of matter? उसके बाद I will try to explain that this state, the states of matter is a classification scheme, जो वर्गीकरण का ढंग है. And then I will try to explain what is the difference between liquids and gases and what is the difference between solids and liquids. I will try to tell you about other states of matter other than solids and liquids, and I will try to convince you that powders is a different state of matter which has properties which are different from solids and liquids. So one should think of it as a different state of matter, and there can be other states of matter which are not even powder, and which some are familiar and some are less familiar. And then I will summarize again once more just to be sure. Okay, so to begin with, I have started with this quotation from textbook, NCERT textbook grade 11. It says, it is well known that matter exists in three forms: solid, liquid, gas. If you have used some other textbook, it doesn't matter. Typically there is some sentence like this in most of these books, and then it doesn't seem to cause any problems. करोड़ों बच्चों ने उसको पढ़ा है, and the teachers ने पढ़ा है, बच्चों ने पढ़ा है, and it is of course very respectable and undisputed statement. Nobody says that this is wrong. But you can ask, why are there three states of matter? Why are there not more? And what exactly is meant by states of matter? Okay, so this is what I will try to discuss. And so the idea is to look again at something which you take for granted and people just repeat it without thinking. And we would like to think about this and try to explain, and you will realize that once you think about some problem a little bit, not infinitely deeply, then you can actually understand it much better, and that is what I'll try to do. Okay, so my aim in this talk is not to tell you about liquids, solids and gases. That you will know already, or you will read at other places. My aim is to make you realize that, you read something in books, some teacher tells you, but if you bother to think about what you are being told and think for yourself, then sometimes it happens that you will realize that within a few minutes of thought that some things you may not be true, or maybe half true. So you are being told something, but it is not true or half true, and you should be able to tell which is which. And so the aim is to help you develop critical thinking, विवेक कहते हैं हिंदी में, which is the ability to separate दूध और पानी, दूध का दूध, पानी का पानी कहते हैं. So you know how that happens, but we will not, ये सब abstract idea हैं, we will explain it using states of matter as an example. So I will discuss states of matter, you know them a little bit, but you will be able to see them slightly differently after the talk. Okay, so, but before I go into all this detail, we still have to answer some of the questions which you will have, or some things people have told me after I give this talk. They tell me that you are talking about solid, liquid, gas, ठोस, द्रव, gas, in sub, but these are just words and they don't have very precise meaning. ये तो बोल चाल के शब्द हैं, इनकी trying to give precise meaning to them is not desirable, not useful, one shouldn't do it. But there are words like force, work, pressure, which are used in everyday conversation. So, and they don't have same meaning. Like I can apply force on some object and make it move, and I can also speak forcefully. And pressure is what air has, there is an air pressure, but there is also political pressure. And I guess political pressure is different from air pressure, right? They cannot be measured in the same way. So, but what happens is that when we use these words in science, we give them precise meaning. So when we use word force in science, then force can be measured always in newtons. We will not use the word speak forcefully except for colloquial purposes. In science, the force will be measured in newtons and will be, it has a standard meaning. Similarly, pressure. So then we will try to see what these words mean. The other thing is, people say that, okay, you are just discussing what is solid, what is liquid. Why don't you just give me a definition and be done with it? I don't want to listen to a 1 hour lecture on this simple topic. You don't like this definition given in my textbook, you give me your definition. But the point we are discussing is not words, but the ideas behind words. So when we say ठोस, solid, we already have something in mind, and can we understand what that is and why are we discussing it in this way. So the third thing I want to say right here is that there are very complicated things like salad and kadhi, which are not simple. So they are in kadhi you have some liquid and solid, soup में बहुत सारी चीजें होती हैं. But we are discussing simple homogeneous matter which looks the same in different parts. It's not mixture of various things. So simple liquids like water or alcohol or some such thing, but not very complicated stuff. The last point, which is a little bit technical, but I would just like to mention it right here, is that states of matter is a concept and phases of matter is another word people use in English. इसको अवस्था कहते हैं और इसको phase को प्रावस्था कहते हैं हिंदी में. So phases of matter is different from states of matter. For example, you can take a magnet and if you heat it up, the magnetism goes away. So it goes from a magnetized phase to an unmagnetized phase. But the state of matter remains solid throughout. So the state of matter is not the same as phases of matter. Phase can change, but the state may not change. States of matter is a bigger and coarser concept of what we are discussing. Okay. As I said, if you have some questions, you should put them in the chat box. Okay. So there are many different materials. And when I think about it in the end, you will realize that in the final analysis, the correct answer is that states of matter is like filing cabinets. So, you have lots of materials, you want to put them into different categories, then it's easier to talk about them, So this is a picture of a filing cabinet. And here is a discussion of other possible ways I could have classified. So I can just classify them alphabetically. Like there are lots of words. So in a dictionary, you just arrange them in an alphabetical order according to their names. Or there are lots of chemicals. And in chemistry, you want to discuss all these chemicals, but you distinguish them by saying they are organic chemistry and inorganic chemistry. That is what we study in 10th grade and 12th grade, right? 12th grade. So, but you can also have different ways, like you can classify according to appearance. There are all these animals, but some animals are dog-like, dogs and wolves and things like that, and they put in one category, and cat-like animals are different category, right? So that is in zoology, they classify animals in trees. In biology, they classify animals in trees according to their appearance, what they look like. I can classify things according to color, blue, red, green, yellow, or something, like that. I can classify them according to electrical behavior, conductor, insulator, if they conduct electricity or not. So all these classification schemes can be used, and they are actually used depending on context. Okay, and so the number of such classes, how many classes are there, that is a matter of convenience. If I make too many classes, then I can join some classes and make a bigger class. Or if I have too few classes, I can break them into subclasses. Okay, so the number of classes is a matter of convenience. So the same way, the states of matter, how many states are there? That is as many as we want. If we said there is a solid, but you can make red solid and blue solids, these are different. If we like to make such distinction, we can make such a distinction, it is not a problem. Okay. So in the chat box, right now there is no, okay, there are some comments about plasma and stuff like that. We will answer them. I will answer the questions about plasma, but let me go on. So the number of classes is a matter of convenience. So what is a good classification scheme as opposed to a bad one? So the basic point about good classification scheme is that it should be, the number of classes should not be too big. If you have 500 classes, that is not very useful. So what we will do is that we will break them into 5 classes, and each of the 5 classes will be broken into smaller ones, like that. So the number of classes should not be too big. And the second property which we like is that there should be unambiguous definition, clear unambiguous definition. Plasma we will discuss. There is a question by Jewish clusters about plasma. What? Bose-Einstein and Bose-Einstein we will discuss later. Okay, I will answer all these questions, but let me just continue just now. You hold your questions for a minute, because they are not directly relevant. See, I have not discussed Bose-Einstein yet. So once we discuss, then I will tell you about them. Okay, so hold your questions and try to follow what I am trying to say, because it is not very deep, but if you worry about other things and not listen to what I am trying to say now, it will work less well. So we would like the definition to be clear and ambiguous. You give me material, I should be able to tell whether it is state 1 or state 2 or state 3. The third thing which we would like is that if you want to classify, if I give you some material and you have to tell is it a solid, liquid or gas, you have to do some test on it. But this test should not be very hard to do. If you can just look at it and tell, that's very nice. But if you have to send the material to Paris for some complicated test, it's less useful. So the test we should be able to do, but it should not be very difficult to do, and that's called ease of classification. What are states of matter? I am trying to describe what is a state of matter, but we start with this sentence which you have read in your 5th grade book, that there is solid, liquid and gas are states of matter. And we are trying to understand what is meant by state of matter. Exactly, that is the question. Okay, the fourth definition, fourth requirement of a good scheme is naturalness and usefulness. Natural means I don't want to make an arbitrary definition. I can say if the density is more than √2 in some units, then it is a solid. This is not an arbitrary definition. It's not natural. So what arbitrary means, why did I choose √2? I can choose √3. Then what happens is that sometimes it may happen, or it does happen, that here people say beyond more than √2 is a solid. In China they say more than √3 is a solid, and then something will be called solid in place A and not solid in place B, and that means that this definition is not useful. So you can put them together, because naturalness is, if it is not natural, it is not useful. And now we come to the basic point, which is that when we say that we classify states of matter as solid, liquid, gas, it is in terms of mechanical properties of matter. जो हमारे पास material है उस पर हम कुछ बल लगाते हैं, we apply some force, see how it changes under the force. So for example, can I pick it up with bare hands, or do I have to use a spoon? That is the distinction between solids and liquids. Okay, so it depends on, can I pick it up with hands, okay, can I apply, can I twist it, shear it and things like that. I'll try to explain this more, but it is in terms of mechanical properties. I gave you examples above which were in terms of chemical properties here. Color, chemical properties, we are not using them. We are not using the names of things. That was alphabetical. We are using their properties in terms of what happens to them when you apply a force. Okay. So now comes the question, why are there three states of matter? And so here I have drawn this picture, which is called a phase diagram. I don't know, all of you may not have seen it. The x-axis is temperature. When I go like this, I increase the temperature. The y-axis is pressure. When I go like this, I increase the pressure. So here I can, this is picture of water. I start from low temperature, it is a solid. Then I heat it up, increase the temperature, it becomes a liquid. Increase the temperature, it becomes a gas. So that is what it is, the solid, liquid, gas we are familiar with. If you take some other material like alcohol, same thing will happen. But now comes the point that it is found that if you increase the pressure and do the same experiment with water, you will have a solid liquid gas transition, but the point at which the transition will occur will change. So melting point will depend on pressure. Similarly, the boiling point depends on pressure and usually increases as the pressure increases. But beyond some pressure, it turns out that if you apply a pressure of some few hundred atmospheres and there is liquid and you heat it up, it never boils. It just remains the same. It just becomes hotter and there is no jump in density. Okay, so that point, the end point where the boiling point change, after which there is no further boiling, is called a critical point. But now what happens is, or it is clear from this picture, that I can go from a liquid state to a gas state continuously without any sudden change in some property. Okay, I can go like this, like this, like this. So then I don't know, suppose here in this picture I want to color the liquid region as red, green and gas region as red, then the boundary between green and red is not very clear where to draw. I can say draw the line like this, but that's an arbitrary definition, and so we said that that is not allowed, that is not good. And so this point has been realized for a very long time, that liquid and gas are actually the same state, and this is called the fluid state. Taral padarth kehte hain, things which can flow, and you cannot really distinguish between liquid and gas. So they are the same state. So now there are no three states of matter, there are only two states of matter. Now, of course, people already asked, what about plasma? Plasma is a different state. It turns out that even plasma should not be thought of as a distinct state. The reason is that if you take some liquid like steam or hydrogen and heat it up, then as the temperature goes up, it becomes ionized. So, instead of atoms, you have ions and electrons, or positive and negative ions, and this degree of ionization increases as you increase the temperature. So at temperature of a few thousand degrees centigrade, hydrogen will have many ions. Then you apply an electric field and it flows. The effect of electric field is much stronger when the material is ionized than when it is not. And so you can use it to make all kinds of stuff, and you can use it to, it can shine, produce light. And so the plasmas can be used in TV or whatever. But it cannot be called a distinct state in the way I am discussing, because it doesn't happen suddenly. The gas will just keep on increasing temperature, the ionization keeps on increasing. So we will not call it a distinct state. I have some good friends who are plasma physicists, and I was talking to them. I said, is plasma a different state of matter? And they just laughed. So everybody knows what it is, but it may be convenient sometimes to call it a different state of matter, but it is not precise, which is what I am trying to do just now. Okay, so now we have only solids and fluids, and I want to know what is the difference between solids and fluids. And again I go to my 5th grade book. It says solids have a fixed shape and fixed volume, liquids have a fixed volume but no fixed shape, and gases have neither fixed shape and fixed volume. and many of these have, you have seen this before. I cannot understand how pressure relates. Means what? Relates to what? Meenakshi Sanehi has said that I cannot understand how pressure relates, but I am not able to follow this point. Okay, we will come back to it. Let me just go on just now. I am not able to understand the question. So here is a very simple example. I take a ball of rubber. The ball is made up of two colors, half of it is colored red, half of it is colored green. And I put it on the table, and that is what it looks like. And then I turn it and put it on the same ball on the table, and it looks like that. Now, has the shape remained the same or has it changed? I guess you will realize that, once you put the ball on the table, then the bottom is a bit squished and it वो दब जाती थोड़ा सा, and so the shape of this is different from this. So the shape has changed a little bit. So is this, solids have a fixed shape, is that correct or incorrect, or is the ball a solid or not a solid? Okay, but you realize that this point I said about rubber ball, but it can be said about anything. All material, even if it was a ball made of wood, it will compress a little bit and the shape change will occur a little bit. So all materials have a finite compressibility, and this definition is not good. We try something else. So then, this is also what I read in some book, it says in solids the atoms vibrate about their mean positions, in fluids they move about all available space. This is a tricky one because I cannot see atoms with my naked eye, so I cannot check if the atoms are moving around everywhere or if they are in a fixed position. So there is a good question about slime. I will discuss it later. Okay. So anyway, let me go on here. It says mean squared. So if you look at the atoms carefully, you will find that in all these cases, the atoms actually, even in a solid, they can exchange position and then they exchange position somewhere else. So they move around, but they move around slowly. So in solids, an atom moves about 0.0001 millimeter in 1 minute. In liquids, they move much more, about 1 millimeter. In gases, about 100 millimeter. So there is these atoms move around in all available space, and their distance they move becomes bigger, but they move more slowly in solids than in liquids. But then if I want to say that, okay, if this rate of movement is less than one number, then it's a solid or liquid, we'll get into the same problem about which number to use. Okay, it is a same. Okay, please use Hindi. Okay, कोशिश करता हूँ मैं हर एक पूरा हिंदी में बोलने की. Okay, so तीसरी परिभाषा, सॉलिड्स में एक पीरियोडिक अरेंजमेंट होता है एटम्स का, और लिक्विड्स में ऐसा पीरियोडिक अरेंजमेंट नहीं होता. तो ये मैंने एक चित्र बनाया है, इसमें पीरियोडिक अरेंजमेंट है और इस वाले में पीरियोडिक अरेंजमेंट नहीं है. तो ये क्रिस्टलाइन सॉलिड कहते हैं और इसको एमोर्फस सॉलिड कहते हैं. लेकिन जो क्रिस्टलाइन सॉलिड है इसमें भी ये परफेक्ट अरेंजमेंट नहीं होता है, क्योंकि एटम तो थोड़ा हिलते डुलते रहते हैं. लेकिन इस पर अगर एक्सरे से फोटो लें तो उसमें शार्प पीक आते हैं, पॉइंट्स आते हैं, और एमोर्फस लिक्विड में ऐसे पॉइंट नहीं आते. तो एक परिभाषा होती है कि सॉलिड में इस तरह का अरेंजमेंट होता है पीरियोडिक, और लिक्विड्स में नहीं होता. लेकिन कई सारे ऐसे सॉलिड होते हैं जैसे प्लास्टिक और एमोर्फस सॉलिड, उनमें भी इस तरह का अरेंजमेंट नहीं होता. तो उनको लिक्विड कहना पड़ेगा क्या? तो ये परिभाषा भी उपयोगी नहीं है, क्योंकि ये जो मेटल जैसे सॉलिड हैं जो पीरियोडिक होते हैं, क्रिस्टलाइन सॉलिड और एमोर्फस सॉलिड, उसमें फ़र्क नहीं कर पाती है. ओके, चौथी परिभाषा ये है कि सॉलिड्स में को शियर मॉडुलस होता है और लिक्विड्स में नहीं होता, फ्लूइड्स में नहीं होता. तो ये क्या होता है, शियर मॉडुलस क्या होता है? इसको अगर कोई समझाने के लिए अगर एक तार ले लें और उसको ऐंठते ट्विस्ट करते नीचे से, तो ऐसा ये अरेंजमेंट है, इसको नीचे से ट्विस्ट करेंगे, छोड़ देते हैं तो फिर वो ऑसिलेट करता है पेंडुलम की तरफ से, टॉर्शन पेंडुलम कहते हैं। तो अगर इसको ट्विस्ट करते हैं तो उसमें कुछ बल लगता है जो उसको वापस लाने की कोशिश करता है। तो कितना बल लगता है इसको शियर मॉड्यूलस कहते हैं। और लिक्विड की अगर ऐसे की कॉलम बनाएं और उसमें अंदर से उसको ट्विस्ट करें तो और छोड़ दें तो उसको वापस आने की कोई कोशिश नहीं करेगी। तो इसलिए इसको कहते हैं कि ये डिस्टिंक्शन है सॉलिड लिक्विड में। लेकिन इसमें भी परेशानी होती है। वो क्या परेशानी होती है कि हमने इसको ट्विस्ट किया और उसको पकड़े रहूँ मैं काफ़ी देर तक, 2-3 मिनट तक या 2-3 घंटे तक, तो जो बल उसको ट्विस्ट करने में लगता है वो थोड़ा थोड़ा कम होता रहता है, समय के साथ कम होता जाता है। इसको कहते हैं क्रीप इन सॉलिड्स। और सोच सकते हैं कि अगर हम उसको बहुत देर तक रखें तो ये बल जो है कम हो सकते हैं, ज़ीरो भी हो सकता है। तो इसलिए इस परिभाषा को इस्तेमाल करने में भी दिक्कत होती है। एक और परिभाषा है जो कि इस्तेमाल नहीं की जाती है, यूजुअली किताबों में नहीं मिलती है, लेकिन मैंने अपने बारे में सोच रहा था, पुराने शास्त्रों में लिखा हुआ है कुछ इस तरह से, नैनम छिंदंती शस्त्राणी, वो तो आत्मा के लिए है, लेकिन जो उसमें था वो कुछ चीज़ें जो हैं वो काटी जा सकती हैं, कुछ चीज़ें नहीं काटी जा सकती। तो सॉलिड्स कैन बी कट विद अ नाइफ एंड फ्लूइड्स कैन नॉट बी कट विद अ नाइफ। ओके, ये तो मानने को तैयार है। लेकिन ये भी पूरी तौर से मुश्किल पड़ता है। इसमें क्या मुश्किल पड़ती है कि अगर हमने कोई फ्लूइड लिया, उसको चाकू से काटा, तो चाकू को जब आगे बढ़ाते हैं तो फ्लूइड 2 हिस्से में बढ़ जाता है, लेकिन वापस आके वो जुड़ जाता है। जब चाकू आगे चला जाता है तो फ्लूइड फिर से जुड़ जाता है, फिर पहले जैसा हो जाता है। तो सॉलिड में भी कई बार ऐसा होता है कि एक हमने मेटल लिया, उसको अगर हम बड़ी सफाई से काट दें, फिर एक के ऊपर एक रख दें, थोड़ा सा हिला दें, तो फिर से वो जुड़ जाती हैं। इसको कोल्ड वेल्डिंग कहते हैं। तो जो चीज़ लिक्विड में होती है वही सॉलिड में भी होती है, इसलिए इनको फ़र्क करना ज़रा कठिन है। तो मैं थोड़ा सा डिस्कशन लंबा चौड़ा हो गया, तो मैं वापस याद कराने की कोशिश करता हूँ आपको। हम कह रहे थे कि जो वर्गीकरण की मेथड है उसमें एक में ज़रूरी बात है कि क्लियर अनएम्बिगुअस डेफिनेशन होनी चाहिए। अगर हम कोई चीज़ दें आपको तो स्पष्ट रूप से आप कह सकें कि सॉलिड है या लिक्विड है। और हमको पता चल रहा है कि इस तरह की परिभाषा देना कठिन है या मुश्किल है। तो क्योंकि हमने कहा कि अगर हम ये परिभाषा देते हैं तो दिक्कत होती है, ये देते हैं तो ये होती है। अनएम्बिगुअस डेफिनेशन है ना, कठिन है। और ये बहुत जनरल प्रॉपर्टी है, ये मैं आपको समझाना चाहता हूँ कि ठोस जैसा या फ्लूइड जैसा बिहेवियर, ये इस पर निर्भर करता है कि किस लंबाई और किस समय की बात कर रहे हैं। अगर हम एक बहुत छोटी सी पानी की या पारे की बूंद लेते हैं तो उसकी शेप बदलना बहुत मुश्किल रहता है। वो स्फीयर जैसी लगती है, इट इज़ क्वाइट रिजिड। अगर हम कॉपर लें, जिसको सब लोग सॉलिड बोलते हैं, लेकिन कॉपर को तो कहते हैं कि वो तन्य होता है, तो उसके तार खींचे जा सकते हैं। तो उसको अगर खींचें तो वो लंबा हो जाता है, इसका मतलब वो लिक्विड की तरह से बहता है। ओके, सो इट मेटल फ्लोज, दैट इज़ व्हाट इज कॉल्ड डक्टाइल, एंड लिक्विड्स ऑल्सो फ्लो। तो वो भी, सो यू नो द डिफरेंस बिटवीन देम इज जस्ट अ टाइम स्केल। मेटल्स फ्लो मच मोर स्लोली देन वाटर विल फ्लो। इसी तरह से अगर एक प्लेन से गिर जाए नीचे and you fall on a lake on liquid, you will break your bones as badly if you fall on a hard ground. ये एक्सपेरिमेंट करना आसान नहीं है, मैं नहीं चाहूँगा कि आप करें, बट इट इज़ अ फैक्ट, दिस इज़ व्हाट विल हैपन। सो अगर आप तेज़ी से गिरते हैं लिक्विड पर या लिक्विड वाटर पर या सॉलिड अर्थ पर, यू विल गेट द सेम बिहेवियर। ओके, सो दैट इज जस्ट okay. So there is one more difference definition, उसको कहते हैं in solids the time average density of particles has a non uniform spatial structure। ये जरा अंग्रेजी में लिखा है, जरा कठिन सी परिभाषा है इसमें कि अगर कोई भी आप मटेरियल ले लीजिए, उसको कुछ समय तक उसके बारे में देखें और समय के साथ एवरेज करें उसकी डेंसिटी को, तो कुछ एरिया में डेंसिटी ज़्यादा होगी, कुछ में कम होगी, तो वो सॉलिड होगा। और अगर सब जगह एक सी हो जाए तो वो लिक्विड होगा। और इसकी परिभाषा पिछली जो हमने शुरू में दी थी, नंबर 2 डेफिनेशन, ये वाली, इससे फ़र्क है। क्या फ़र्क है? कि इसमें हमने ये नहीं कहा कि वही पार्टिकल नहीं फिक्स किया है, सिर्फ डेंसिटी यहाँ पर ज़्यादा है ये फिक्स किया है, और ये भी नहीं कहा कि ये पीरियोडिक है या नहीं। तो ये एमोर्फस सॉलिड्स में और नॉन एमोर्फस सॉलिड में दोनों में ये परिभाषा सही लगती है। ये अभी तक जितनी परिभाषा दी गई उनमें सबसे अच्छी है। लेकिन अभी इस विषय पर थोड़ा सा और आगे बढ़ते हैं। तो जैसे पाउडर होते हैं, जैसे सैंड है, गेहूं है, आटा है, तो इन सब चीज़ों को ये सॉलिड है या फ्लूइड है? अगर आटा लेते हैं एंड यू पुट इट ऑन in any bottle, then it takes the shape of the bottle, so it looks like a liquid. But or you can pour it from one container to another container, again it flows. But then in other ways it looks like a solid, like you can pour sand on a table and it forms a pile. इस तरह का शंकु आकार का पाइप ढेर बन जाता है। लिक्विड में ऐसा ढेर नहीं बनेगा। So this thing can keep its shape like this, and so that is called its behavior different from liquids. So for fluids, this angle will, so this angle जो horizontal के साथ बनता है इसको angle of repose कहते हैं, and for fluids this angle of repose is 0. Okay, so this we already mentioned that you can pour powders from one sugar, you can take sugar and you can pour it from one cup to another cup, but the behavior of sugar is different from behavior of liquids. What's the difference? If you put sugar in a jar and measure the pressure at the base of the jar as of when you increase the height of the sugar column, so in case of sugar the pressure becomes maximum and then it remains the same. But in case of liquids, the pressure keeps on increasing as you increase the height. So that's the difference. Okay. Also, if you make a conical pile and you look at the pressure at the base of the pile, मैंने कोन जैसा पाइल बना दिया और यहाँ पर मैं मीटर लगाता हूँ और उसका प्रेशर मेजर करता हूँ, तो हम ऐसा देखते हैं कि प्रेशर कुछ ऊंचा हो जाता है, फिर बीच में जाकर वो कम हो जाता है, फिर बढ़ जाता है, फिर कम हो जाता है। ऐसा बीच में कम क्यों हो जाता है ये समझना मुश्किल है। ये मैं इस समय नहीं समझाऊंगा, लेकिन सिर्फ इतना बता रहा हूँ कि ऐसा बिहेवियर लिक्विड्स में नहीं होता। ओके, तो थोड़ा फ़र्क है। एक और फ़र्क है, जैसे ये वाटर है और इसमें नीचे बर्तन में छेद कर रखा है, तो नीचे से बहेगा। किस स्पीड से पानी नीचे निकलता है ये इस पर निर्भर करता है कितनी ऊंची कॉलम है। अगर इसमें ऊंचाई बढ़ा देंगे तो स्पीड बढ़ जाएगी। लेकिन अगर सैंड हो और वो भी ऐसे बहती है, लेकिन इसमें अगर नीचे गिरती है सैंड, उसके नीचे गिरने का रेट हाइट पर ज़्यादा निर्भर नहीं करता। सो इट रिमेन्स द सेम इफ़ यू इंक्रीज द हाइट। ओके, एक और इफेक्ट होता है, इसको ब्राज़ील नट इफेक्ट कहते हैं। ब्राज़ील नट इज़ लाइक अखरोट। सो इफ़ यू टेक कॉर्नफ्लेक्स एंड यू शेक देन दे कम ऑन टॉप। मुझको बताया गया है कि इफ़ यू टेक कैनन बॉल्स, तोप की गोले, एंड पुट देम इन सैंड एंड शेक द बीकर, देन ये तोप लोहे के गोले होते हैं, वो ऊंचे होते हैं, भारी होते हैं, लेकिन वो ऊपर आ जाते हैं हिलाने से। जबकि अगर लिक्विड होगा, वाटर होगा, तो उसमें ऐसा नहीं होगा, उसमें वो नीचे बैठेंगे। तो जो आर्किमिडीज का नियम है वो पाउडर्स में नहीं लगता, जबकि फ्लूइड्स में वो लगता है। तो इसलिए पाउडर्स को फ्लूइड नहीं कह सकते। ओके, और भी कुछ होता है कि जैसे नॉर्मली कुछ अगर चीज़ों को हिलाएं तो वो ज़्यादा जुड़ एक यूनिफॉर्म हो जाती हैं। जैसे अगर दो तरह के लिक्विड हों और उनको शेक करें तो वो मिल जाते हैं। लेकिन कई बार इसमें एक ट्यूब है, इसमें दो तरह के ग्रेन हैं, रेड एंड ग्रीन, और उसको पहले से वो एक साथ जुड़े हुए थे, जब उसको ऐसे घुमाते हैं तो अलग हो जाते हैं, और रेड ग्रेन एक जगह हो जाते हैं, ग्रीन ग्रेन एक जगह हो जाते हैं। जबकि नॉर्मली यू माइट एक्सपेक्ट कि इसका उल्टा ही होना चाहिए। ओके, सो ये मुझको, जैसे मैंने कहा था कि मेरा उद्देश्य सॉलिड लिक्विड को डिस्कस करना नहीं है, ये डिस्कस करना है कि ऐसा क्यों होता है। लेकिन और क्या स्टेट हो सकती मैटर की। सो पहला सब होगा कि यस और भी हो सकती हैं। जैसे ग्लासेस होते हैं, जो विंडो ग्लास है, शीशा कांच, तो उसको सॉलिड भी कह सकते हैं, लेकिन अगर देखा गया है कि अगर बहुत देर तक, बहुत सालों तक ग्लास की विंडो को रखें तो ऊपर से पतली हो जाती है, नीचे से ज़रा चौड़ी हो जाती है, तो वो बहुत धीमे धीमे बहता है। तो इसको बहुत विस्कस लिक्विड भी कह सकते हैं, जैसे शहद होता है बहुत धीमे धीमे बहता है, उससे भी बहुत ज़्यादा धीमे बहता है। लिक्विड क्रिस्टल, ये जो है लिक्विड क्रिस्टल जो आपके डिस्प्ले आदि में, रिस्ट वॉच आदि में होते हैं या टीवी स्क्रीन पर होते हैं, वो पानी की तरह से एक बर्तन से दूसरे बर्तन में फ्लो करते हैं। लेकिन वैसे अगर एटॉमिक स्केल पर देखें तो उसमें सॉलिड की तरह से क्रिस्टल जैसा अरेंजमेंट होता है। सुपर फ्लूइड, सुपर सॉलिड, ये कुछ एग्जोटिक चीज़ें होती हैं जिसको सामान्य जीवन में नहीं मिलते, लेकिन हीलियम को अगर बहुत कम टेम्परेचर पर करें तो वो उसकी प्रॉपर्टी बदल जाती हैं, उसकी प्रॉपर्टी काफ़ी फ़र्क हो जाती है, उसको नॉर्मल लिक्विड नहीं कर सकते, वो बिना किसी बल के भी बह सकती है, तो इसको सुपर फ्लूइड कहते हैं। तो सुपर फ्लूइड से इतना फ़र्क है कि इसको अलग क्लास में डालना बेहतर रहता है। और भी चीज़ें होती हैं, कोलोइड, जेल, एमल्शन, फोम, जो जिससे शेविंग क्रीम आदि होते हैं, तो ये सॉलिड हैं या लिक्विड हैं, तो उस पर कहेंगे कि ये तो पता नहीं कि होमोजीनस है, यानी फोम में कुछ हवा होती है, कुछ लिक्विड होता है। इसी तरह से एमल्शन भी, उसमें होमोजीनस कहना मुश्किल है, तो इसके अभी हम डिस्कस नहीं करेंगे। लेकिन जस्ट न्यूट्रॉन स्टार होते हैं जो न्यूट्रॉन के बने होते हैं, जबकि बाकी मैटर जो है वो एटम्स का बना होता है, तो इसके गुण काफ़ी फ़र्क होंगे। तो जो न्यूट्रॉन मैटर है उसको फ़र्क फेस कहना उचित होगा। इसी तरह से क्वार्क-ग्लूऑन प्लाज्मा है, उसको फ़र्क मैटर कहना उचित होगा। डार्क मैटर होता है, उसको फ़र्क कहना मुश्किल होगा। शुड वी अवॉइड जंक फूड? मैं इसका भी जवाब देता हूँ धीमे धीमे। पहले मैं इसको अपनी इसी बात को ख़त्म कर दूँ, फिर मैं आपके सवालों के जवाब देता हूँ। ओके, सो ये समरी पे आ गए हम, और बाकी खत्म नहीं है। सो सबसे इम्पोर्टेंट चीज़ जो मैंने आपको बताने की कोशिश की वो ये है कि अपने आप इस विषय पर सोचें। दूसरा ये है कि हमको ऑफकोर्स जो किताबें हैं, टेक्स्ट बुक हैं, बच्चों की पाठ्यक्रम की किताबें हैं, उसको उसमें गलत चीज़ें नहीं सिखानी चाहिए। तो मैंने देखा कि कई बार शब्दों में थोड़ा सा बदलने से वो सही हो जाती हैं। जैसे एक केमिस्ट्री की किताब है ये मैथ्यू की, इसमें लिखा है ऑलमोस्ट ऑल सब्सटेंसेस फॉल नीटली इनटू वन ऑफ 3 क्लासेस। ये पहले जैसे हमने लिखा था ना कि सब्सटेंसेस फॉल इनटू 3 क्लासेस, सॉलिड, लिक्विड, गैस, इसमें सिर्फ इन्होंने कहा ऑलमोस्ट ऑल। तो इस ऑलमोस्ट ऑल जोड़ने के बाद ये वाक्य सही हो गया। और मैंने आपको समझाने की कोशिश की कि जो स्टेट्स ऑफ मैटर हैं ये इस पर निर्भर करता है कि किस लेंथ की बात कर रहे हैं, किस टाइम की बात कर रहे हैं। तो जैसे एक ट्रक हो जिसमें बहुत सारी ईंटें हों, सो उसको उलट देते हैं तो वो नीचे गिर जाती हैं, सो इट फ्लोज लाइक अ लिक्विड। और हमने बताया कि ग्लास इज इट लुक्स, वो एट लार्ज लेंथ के टाइम स्केल्स it flows like a liquid, at small times it looks like a solid. Powders and superfluids are different states of, they are different from solids and liquids. They should be considered a separate state of matter. But more important than this, what I want to discuss is that there are many things which are not understood even in the kinds of things you see every day. जो कई बार ऐसा होता है कि स्टूडेंट जो हैं they only want to discuss what happens at the scale of universe, or what happens at the scale of subparticles, but at human length scale there are many questions which are not answered, which you can try to answer and then you will understand them well. Okay, so this is the end. Now let me deal with some of the questions. Okay, so why are there 5 states of matter? ये समृद्धि ने पूछा है, and I think I have answered you कि the number of states of matter is a matter of choice, and I gave you many examples of other states of matter which are different from all the ones you have studied. What is a plasma? ये भी डॉक्टर विद्या ने पूछा. I have answered that plasma is in some materials at high temperature it becomes ionized. When the degree of ionization is more, then the effect of electric fields is much stronger, and it is called plasma state. What is Bose-Einstein condensate? Okay, at very low temperatures, some quantum mechanical effects come in and the behavior of the material becomes very different. And so then it is called Bose-Einstein condensate. Okay, there is a question from Bhagwan Chakradev. Can we say superconducting matter has special state? Yes. So certainly if you take some material, you cool it down, then it becomes superconducting. Uski conductivity is infinite ho jati hai. Okay. So then we say there is a phase transition from non-superconducting to superconducting state. But it is, in my way of speaking, it was still a solid in both cases. Okay. Nima Kumari ने पूछा है कि how to introduce 5 states of matter in class 6th and 8th. So I have said that you can have 5 or 8 or 10. The number of states of matter is not an issue, but the fact that you can have sufficiently different behavior in material such that you need to put a new classification. कोई एक नया animal मिला है which is totally different from all the animals I have studied before. Then maybe I make a new class, zoological class जिसमें वो डाल देंगे. What is the state of matter of black hole? Okay, so black hole is not a standard material, and again it's a matter of definition, but it is not very useful to talk of state of matter of black hole. मैंने तो कभी देखा नहीं है, and I don't know how to handle it. I don't know what happens if you apply force to it. So it's a tricky question. You can discuss such issues, but I will not worry about them today. I am sidestepping the question, saying it's a difficult question, and it's a matter of, you can call it another state of matter. I allowed you, saying a new state of matter. Black hole is the 10th state of matter. Okay, that is allowed, but it will not cause any problem. But it is not very useful to speak of this, because then what's the use of calling it 10th state of matter, right? So that is the way I would like to answer it. What is the state of matter of slime? This is a good question. Slime is actually like kichad. So it is a mixture of powder and liquid. There is dry powder and wet powder. If you have dry powder, it is what we discussed here, and if you have wet powder, it is much more complicated behavior. So maybe I want to call the wet powder a different state of matter. That will be perfectly reasonable, and that is what I will say. Okay, now state of matter of neutron star. So I said that neutron matter will be a different state of matter for sure. Okay, and what is state of matter of light? This is asked by Kanchan Panse. So this is a sort of is light matter or not matter? At least the usage we have seen, जो हमने प्रयोग देखा है, उसमें usually light is not called matter. Sometimes some people have called light matter, and I would say that it is better to think of light not as matter. So जो matter वो होता है जिसकी कुछ mass होती है, and light doesn't have a mass by itself, it has only energy. Rest mass नहीं होती. So if you don't have rest mass, then I will not call it matter. So that is what I would say. Are there different types of matter which are not discovered? Of course, there are many things which are not discovered, and we work with the idea that we can discuss them more. Please tell the difference in phase and state. We use these terms interchangeably in school books. Please transform temperature mentioned in the book. Okay, phase transformation. So I mentioned it actually. So change of phase is like even a magnetized state is to an unmagnetized state is a change of phase, but it is not change of state, because both of them are solid. So phases are finer classification, ज़्यादा सूक्ष्म वर्गीकरण है. So you can change a phase without changing the state. That is what I would say. Okay. Other questions. You can even use chat box is okay, or they can even ask. Chat box is good. So I am reading. What is the 10th state of matter? I was making a joke about 10th state because I said the number of states of matter can be whatever you want. So I actually mentioned 7 or 8. So I'm saying that, if you want black hole to be another state, then it is the 10th, 9th, 10th, 11th state, like that. Okay. Define fluid. Fluid are things which flow. Okay. So usko Hindi में कहते हैं तरल पदार्थ. And so gases and liquids both flow and solids don't flow. So उसको कहते हैं ठोस और तरल. Okay. Electron. Recently I heard about light gas. Okay, light gas is a light जो अंग्रेजी में शब्द है उसके होते हैं light and heavy. But light as a, if you take a box in which just there is some light and there is nothing else, so it is a sort of, you can call it a gas of photons, but it is different from what I call matter. So I will say light is not matter. Okay, please tell us something about the simplest definition of matter. Okay, very good. So what is matter? So I would say that things which have finite mass can be called matter. Matter, in this way I am distinguishing from energy, because if you just have photons, they have energy, but I was not calling it matter. Okay, it is just a name. It doesn't, if somebody says that I will want to consider energy also as matter, then I cannot say that your head will be chopped off. It is not illegal, but it is not convenient. See, the use of all these vadikaran or classification or names is that it helps us think about them and talk about them. So does it help me to say that light is matter, or does it help me to say that light is not matter? I would say light is not matter is better than saying that what do you think about dark light? Okay, dark light, I've never heard about it, but if you cannot see, then maybe it is dark and it is made up of photons, so I want to still call it light. So ultraviolet light may be dark light, or infrared light may be dark light. Can gravity act on energy? Yes, the gravity does act on energy. In Einstein's theory, all energy causes things to attract each other. Dark matter, does it have any weight at all? Yes, it has. Actually, it has not been seen. So dark matter as of today is a hypothetical object. People are guessing what it might be. Nobody has seen that it has mass or it doesn't have mass. They are guessing its properties. And so I think it can be left at that level. What do you think about dark matter? I actually don't know much about it. So what I have read from places is that dark matter is because there is universe and it is expanding, but it is expanding, it seems like there is much more mass than we can see. Then you say it is dark matter which we cannot see, but it is still there, some mass is there I cannot see, so that is called dark matter. Why people think infinite electricity is fake? Infinite anything is not fake, but it is not easy to achieve, right? You cannot achieve infinite electricity, infinite matter, infinite anything. Does antimatter exist? Yes, people have produced positrons and antiprotons and objects like this, and they have even created anti-hydrogen atoms, made up of antiproton and positron. So antimatter does exist. Where and when can antimatter exist? Antimatter exists, but it, if it comes in contact with matter, then they annihilate, and so you have to keep it in some special bottle which is not made up of ordinary matter. So it is hard to do, but you can produce it for a short time. How many states of matter? I already answered it. Dark matter is solid or liquid. So this is, nobody knows. Nobody has seen dark matter. They haven't studied its behavior. They don't know what happens if you apply forces on it. So nobody knows. Sir, equator means difference between matter and substance. I think they mean the same thing. Why do perpetual motion machines fail? that is outside the regime just now. I will not, there are many questions, but I cannot answer all of them. So we will restrict the questions to things dealing with this topic, not all possible questions. Okay, so Meenakshi Sanehi says gamma ray burst, but it doesn't say anything more. So anyway, I didn't discuss gamma ray burst, so I will not talk about it. Black hole is really a state of planet-like thing. So black holes are, you start with a star and it collapses onto something like a point, and then you cannot actually see it from outside very well. Light has mass in the sense that it attracts other things to it, or it gets attracted by Earth. So it has, it has mass in this sense, but it doesn't have rest mass. If you cannot bring light to rest, so it doesn't have rest mass. And I was saying that in this sense, light is not matter. Okay. Okay, so we can stop here now. Other questions? I will send you some email if necessary. Okay, we will stop here because it is long enough.